Hi friends, welcome to Mechanical Explorations. Now in this part we are going to see another important concept regarding thermal resistance. We are going to solve this by using Ohm's law and it will be used to solve the composite layer problem. Before going to that, you need to understand how the composite layer of problem looks like, and you can see this is an example for a composite. You can see that of bodies like which are being merged or mixed like that. A is here and B, C, D, E, F and G, H. Like that only. You already know about composite. I just want to show you how the problem they will be giving. So in order to solve this, what you will be doing, you will be in resistance. You will be taking year 1 resistance, year, and you can see that it is parallel. And for A and BC, it is series. For B and C, it is parallel. Like DEF, it is parallel, GH, it is parallel, and you can see the equivalent resistance diagram is been given like that only. And you can see this is RA, and you can see that BC is parallel, so it is given in parallel, and these three things also in parallel, so it is in given parallel. Hope so you understand how to address the composite exam problems. So now moving on to here, you can see the concept of resistance is valid for steady state, in which there should not be any internal heat generation. This is one important concept that we need to assume all those things, right? That is the thing here we are assuming. And you know that the reciprocal of thermal resistance is thermal conductance. Now coming to the concepts, you can see here. See, this is considered as an electric conductor, and it is current is flowing. There is a voltage difference. And you can see this is arc electrical. If there is a electrical resistance, then the formula will be rho L by AC. You already know these things. When 1 by rho is inversely, that is conductivity. Conductivity is inversely proportional to resistivity, like sigma inversely proportional to rho. We are substituting here. And you can see this is Ohm. See, this is electrical quantity which is inversely proportional to resistivity. And we are getting that I equal to V by R. We already know this equation, Ohm's law, V equal to IR. Same thing, just we are rearranging all those. And you can see when I'm coming to thermal conductivity, same, but in here it is voltage difference, here it is temperature difference. Here the current is flowing, we need heat because it is generated through electrons accumulation, right? We have already seen how the heat is being generated. And now here thermal resistance, and you can see that I directly, which is Q. Here it is I, here it is Q. And similarly for voltage drop, it is thermal temperature difference. We are rearranging this. If we rearrange this, we will get this formula. I for Q, V for T, and the resistance will be electrical resistance here. Here it will be thermal resistance. Now the unit you already know. For temperature it is Kelvin or degree Celsius, and for heat it is watt joule per second. This is the basic outline, just I said only outline. Now here is the main thing. We need to solve the problems regarding here only. They will be giving one plane wall or one hollow sphere. Initially we will go with plane wall. Most of the cases plane wall is given. Now the temperature profile is already given. We have found the temperature profile in our previous lecture itself, like we derived. So from this temperature profile, for plane wall it is Q equal to T1 minus T2 divided by L by K. We already know this, and we need to substitute this equation Q equal to del T by R. If we substitute here, we can see that this R is L by K. That is, this is the resistance for the heat. When this value is small, heat conduction will be high, and this value is large, heat conduction will be low. Same thing for hollow cylinder also. This temperature profile we already derived in previous lecture. We also said this is a logarithmic because ln is there, and we have said this is hyperbolic, R is there. So like that, it is in base, right? So we are taking this as resistance. If this is decreases, this increase. Simple thing only. Here we need to make sure we need to rearrange this equation in such a way the temperature profile is directly proportional to Q. That is, temperature is proportional to Q, and whatever in the denominator, it is resistance. So same thing I have taken for hollow sphere also. Same, this thing is R, and we have found out for a resistance in hollow sphere also. Now one important thing. These are the important things, and if you remember this formula only, that is temperature profile formula only, we can able to solve the questions based on resistance in plane wall or hollow sphere or hollow cylinder also. And now the convection heat transfer, it is, you already know HAS del T. When it is when you are taking what I said, the temperature profile should be directly proportional to temperature difference, should be directly proportional to heat. When it is directly proportional, this thing will come into denominator, so that 1 by HAS, this will be the resistance, that is going to be the convective resistance. We will be seeing how the we have already derived Newton's law of cooling, right? And R convection equal to 1 by HAS. Same thing, whatever we have said here, how we are taking the steps, same we are taking here also. And this is the convective heat transfer. You know, if the air is blown over this hot surface, entire heat will be carried by the air. And now coming to another important term, that is plane wall connected in series with actual contact. See, this is one plane wall, this is one plane wall. We are connecting this in series. It is not parallel. Here one it is, here another thing. Only you can see series is like this, it will be here one, here one. Parallel means here one and here entirely one. For A, B and C is parallel. Sorry, for A, B and C is series. For B and C only, both the things are parallel. And now this is parallel. What I said, with actual contact. It is actual contact. And this is convective heat loss from the boundaries, not convect. Please make sure as convective heat loss from the boundaries. That is what it means. Convective heat loss means, you already know, if the air is blowing over the hot surface, the air will carry the entire heat. So that is termed to be convection. When convection comes into picture, only the surrounding, it is been coming here. You can see T alpha infinity, that is T infinity, and HI, that is, these things are convective, and this is also convective. Why here I means it is inlet, here O it is outlet, that's all. Here ambient, you already know, I have already said all those things regarding alpha infinity, which is termed to be ambient. You have seen my previous lectures, I think so. Next, if they are giving a problem, how to address this thing, that is the main thing we are going to see here. Another things like deriving at the solution, that is given data, we are just going to substitute, but before that we need to address the problem, how to address the given data, and with the help of diagram, how to we proceed the problem is our first thing. See, here I have said that we have seen taken the convective heat transfer. Here convection is there and here temperature is there. What happens when this air is blowing over this surface? It makes a contact with this surface, right? So what happens in this means, there will be resistance will be developed between these two, and similarly the same thing. But here you have to make sure another important thing, when there is contact, there will be not like simply contact, here the temperature will be same, here the no, it's not the temperature is same. You can see that here some phenomenon will occur. That is the thing I have exaggerated here. You can see there is two temperature, that is C1 the temperature here and C2 the temperature after. What happens when two surface is been in actual contact? And before that, you need to know one important thing. In practical cases, surfaces are rough in nature. And when you are joining, there is no possibility of perfect contact. Here we said it is actual contact. Okay, when there is joining, there is no perfect contact possibly, and we are considering here, so I am explaining. See, during joining, some cavities form in that is, these cavities are being formed, and this cavity may be some fluid trap. See, inside there is fluid, that's what I am saying. There is fluid, and due to the low value of K, the fluid, there is additional resistance. What happens? The thermal conductivity inside it is low. When the thermal conductivity is low, obviously the resistance will be very high, and there will be some additional resistance in this, because it's a fluid property, right? There will be the conduction will be low, that is thermal conductivity, which is denoted by small k, it is low, so there will be some additional resistance. That's why we are taking the resistance in between these two surfaces, that is two bodies. You can see here TC1, TC2. Here we are taking resistance. We are not just going like this is TC1 and this is TC2. No. Why? Because due to the low value of K in the fluid, there may be some resistance. That resistance, fluid resistance. This is fluid resistance and this is spot. You can tell this things as spot, right? This thing, this thing, this thing. Here it will be fluid and it will be spot. So I need to understand you clearly. And T2 will be there. Same thing for how we have taken T inlet and T1. Same thing here also some resistance will be there. You can see here T2 and this is T infinity, that is T ambient out. There will be also some resistance. Here also some resistance. Whatever the things I have said, here it is there, right? Here one resistance will be there between these two on resistance and this two on resistance, this is material resistance itself. See T1 TC, this material will offer some resistance, right? Same thing, this body will offer some resistance due to this fluid. Here we can see that the spot and fluid offers resistance. Here it is of RF. Now we are simplifying this into a series and we get our contact. Simply we are making the parallel. We need to know how to convert a parallel to series, right? This is our main thing is we need to address the problem and we need to simplify like this in terms of this diagram. From this equivalent resistance, you need to know how to draw. Then only you can solve the problem. There is nothing in that problem. They will be giving Q value, R value, T value, something they will ask you to find what is the Q value, like that. Simply you can substitute the value. Before that, you need to know how to draw the equivalent resistance diagram. See, now you can see that actually this temperature difference divided by resistance is the conductivity Q. You should write initially itself Q equal to T infinity I minus Ti divided by Ra. That is Q equal to this Ra will be coming downwards. Simply you can write initially itself. Same concept you apply for everything, you will get every result. Now if you are asking in problem to calculate the overall Q value after giving this much value, they will be giving the problem. Now you want to calculate only Q value. What you will do? You just need to rearrange all those things. That is, take everything, that is Q directly proportional to temperature, right? You will be writing every temperature term in the numerator and every resistance term in denominator. When writing resistance term, temperature term, you will be getting this. That is Q equal to T infinity minus T infinity outside. Because this T1 cancel, TC1 cancel, TC2 cancel, T2 cancel, everything is cancelled. And here the resistance will be same, right? Next, if they are asking for the temperature T1 and T2, what happens? You can write, you can leave these things. You can limit up to T1 and T2, and that's what I have written R1, R contact R2, and there will be T1 and T2, T1 minus T2. So hope so you understand all those things, like how it is came, like it will be T1, right? These things will be not there. So T1 only will be there. TC1 will be cancelled. TC2 will be cancelled, and T2 will be there. We are not taking this thing and this thing into account. And you can see, first you need to see there. TC1, TC2, I have said that fluid, this is a fluid resistance and it is spot resistance. See, fluid resistance and spot. Same thing we are again writing. And if you are converting these things, you can convert these things like Q1, Q2 equal to Q means the R contact value, what will be the R contact? That is the thing. Q equal to Q1 plus Q2. Next, Q equal to temperature difference. That is temperature difference by R contact. Same thing here also. Temperature difference by fluid resistance. Temperature difference of the spot divided by spot resistance. Simply all del T will be cancelled and you will be having these things. If you reciprocal this thing and you will multiply both those things, you will get R contact. This is a very easy thing, and we already seen that R equal to 1 by HIAI, that is convective transfer. Q equal to HIAI. Here we have seen this, right? Q equal to, here Q convection equal to HIS del T, that is Q convection del T by R, that is, this R is 1 by HAS. Same thing I have written here, 1 by HAS. For A it is inlet, and 1 it is the material, first material, and 2 is the secondary material, and B is the outlet. Same thing we are writing. Hope so you understand. But the important thing you can see here is the area only. See, area is HW, that is height into width. Please make sure that we have already discussing these things only. H into W, H, this is W width. Because whatever the length is taken, here the vertical lines isotherm will be flowing. That is isotherm, we have already discussed, the temperature will be same in this line. The vertical lines will be there. For this vertical line, only the heat transfer will be perpendicular to this vertical line. That is the heat transfer where it will flow to this perpendicular area only. When we are changing the length, it doesn't matter for this heat flow, because it is flowing in perpendicular area, right? It is concerned about H and W. It is not about L. That's why we are taking area equal to HW. I already stressed this many times, but I want to tell here also, you should not take L and all, because we are seeing in perpendicular direction only the heat is flowing. Hope so you understand this very well. Now what is the thing here? It is perfect contact, no convection. See, already I said there is no perfect contact. When you are taking this perfect contact, it is imaginary. We need to solve the problems, right? See, this is one body, this is another body, this is K1, K2. The temperature is being given like this. This is internal temperature, this T1 and T2. Same thing. We are not discussing about convection. So T infinity I, that is ambient temperature inlet and ambient temperature outlet, and heat transfer convective heat transfer coefficient of inlet, convective heat transfer coefficient of outlet won't come into picture. So no convection is there. Simply you are writing all those equation, and you need to find the, if they are asking to find the value of K, this is the thing. This is T1 minus T2 divided by R1 minus R2. T1 minus T2, R1 minus R2. And if you want to find individually, that is for resistance R1, Ti minus T1 R1. Ti minus, this is Ti. Make sure this is Ti minus T2 R2. If in problem they have specified the resistance, both the resistance are same, that is R1 equal to R2, if they are giving, then what happens? Simply this two resistance are same, means it is same, right? Then you will be getting the value of 2, that is same. Then what happens? You rearrange the equation, T1 minus Ti and T2, both the things are same, it will be cancelled, right? So then T1 T minus Ti equal to Ti minus T2, and you will getting the Ti value, that is T1 plus T2, here divided by 2 will be there. See, this 2 will be coming to the denominator. So when the R value is same, this is the internal temperature generated. These things you need to see for problem. See, if they are giving a problem like this, one side there is one material fully, another side there is one material, another of there is another material. This is like composite. I given here because we just need not to see the problem blankly. We need to have previous experience, right? Like this. And if you see, this is 2 are parallel, and this is series with this 2. Okay, and you can see the height is this much and with this much, and this is 1/3 of the height, this material, and this is 2/3 of the height, this material, and the length is given L1, this is L2 equal to L3, this length is given. See, first we address the problem. Like, if they are giving like that, how to draw the equivalent resistance diagram? That is the main thing. First, this body will possess one resistance, that is R1, T1, T2, and this body will possess some resistance, that is T2, T3, that is R2 and R3, R2, R3, this is in parallel. See, T2, T3 will be that. This is the equivalent resistance diagram, and when you solve this, you will getting a resistance in parallel, that is you can make this equivalent resistance, right? And you know how to solve, right? That R2 dot R3 equal divided by, initially it is plus, that is 1 by Rp equal to R2 plus R3 divided by R2 into R3. If you are reciprocaling, you will be getting this thing. And you can see that resistance Here how much it will be there, L by K. We have already seen this n number of times, and I have already said this also n number of times. That is area, why it is H and W. L is not coming into picture because it is traveling in this perpendicular area only. And whatever things you can see, I have given notes here, like these things we have discussed. I have said that in practical case, surface or roughness in nature. See, during the joining, no possibility of perfect contact. Here we have seen perfect contact. Here we have seen perfect contact because we have imagined like perfect concept. Because in problem they will ask perfect contact. We should not say that I won't solve the problem because it is not perfect contact everywhere. Perfect contact is not possible everywhere. If there it is given, you have to solve, because we have to imagine, right? During joining some cavities, that is, if you join the perfect contact, there will be some cavities formed in that. That is, that cavity will build by some fluid trap. We have seen previously, that is, fluid trap will be there. Fluid trap will be there. Actual contact, fluid trap will be there. Here and all, why we haven't taken? See, we haven't taken like, they are not specified anything. I have just given the outline how to solve the problems. If in the problems they are giving the things, we have to take. We will see in problems that things. You need not to worry. And if there is K values very low of the fluid, then there is resistance developed. So that only we have seen there RF and also R spot. I hope so you understand. And the resistance offered by fluid and contact, that is C, R spot. Oh, everything is given. R spot at the contact surface as the thermal contact resistance, that is R contact. And there is no equation to find R contact. See, because R contact we need to find experimentally, right? So there is no equation. You need not to worry about this. See, mainly these things, some interview point of view, R contact value mainly depends upon surface of roughness, type of fluid, intensity of compressive fluid applied on the end of surface. Before that, if you want to understand what is surface and surface roughness, I have already made one video on surface roughness. I will be giving that video description, that video link in this video description. You can see that, so that you can understand elaborately what is surface roughness, RA value, how the surface things are varying. So it will be useful for you. Now here you can see all a cylinder connected in series with heat loss from the boundaries. We have nothing but simply all a cylinder is connected in series with heat loss. Here I need not to stress much things because we are going to derive in R and R value. That is, we already have these equations, we already have the resistance value. In gate point of view, you need to take this formula only, and this is the derivation. But I need to stress one thing very carefully, that is, see, if K1 is less than K2, what happens, which means RA minus RB positive means this RA value is positive, and what happens, this QA is also less because thermal conductivity and heat transfer. That's why whenever the K value decreases, initially decreases, initially it will be low. When K value afterwards it is increasing, conductivity also will be increasing. Same thing. This simple thing I just need to discuss because we have taken here things like hollow cylinder. You can see we have solved a lot of things, and why I am need to say that RA minus RB is positive. If K1 less than K2, it is positive. And you can see these things. In order to reduce heat loss from pipe, first layer of insulation should have low value of K compared to second layer of insulation. You can see what happened. You need to reduce the heat loss. You need not want the heat to go out. Then there will be two layer of insulation. You make that the first layer of insulation should be very low K value. What happens, very K value low means the Q will also low. Then K value high means Q will be high. Your first itself, you have made sure that you are not allowing more amount of heat to pass through the surface. Next, second value, okay. First itself, your main criteria is to control, reduce the heat loss from the pipe. In next lecture, we will be seeing the critical thickness. There we will be addressing everything very clearly, like what are the things we are going to do in insulation, why the critical it is conduction is maximum in this critical thickness, everything will address that. So from here I need to say these things only, because in resistance point of view, this is a very easy questions, you need not to lose any marks in that. So I have described everything in detail. If you have any queries, you can leave the comments or you can mail me so that I can see and reply you. Hope so you understand all those things, friends. Thank you. See you in next coming videos.
If you like my videos, please subscribe to my channel.